Hello, this is Dr. E, and for today we're going to be working on congruency of triangles in our geometry lesson. We know that it's really challenging for most of us to write two-column proofs, and for today we're going to be working on some techniques on how to write two-column proofs and answer problems involving triangles, involving the congruency of figures. So by definition, congruent figures have the exact same shape and size, and as shown in the diagram that you are seeing right now, even if you flip, rotate, or slide, the figure does not change, or its shape or figures will stay congruent because they still have the same shape and size even though you move it around, similar to this one. So flip it. So this is our figure. So let's say that this is our geometric figure, and if you flip it, the shape will still be the same, its measurement will still be the same, even if we rotate it and even if we slide it down, their shape is still going to be the same as the original shape, which is this shape, because of our definition of congruency. So that's basically how we define congruency. So given that we have a triangle ABC and triangle TRS, we know that their corresponding angles and corresponding sides are congruent because of the markings that you are seeing on the figure. So here, angle A is corresponding to angle R, and the reason why they are corresponding is because we have three lines or three curves or three markings on this corner and on this corner, so that means they are congruent, therefore they are corresponding. Line segment AB has three lines and line segment RS has three lines, so they are also corresponding and also congruent because of that marking that we are seeing. So that's how basically we denote congruency and corresponding parts of our triangle by just looking at the notations and markings that we are seeing in our figure. And by notation, we write it out as so. So we have here corresponding angles that are congruent. A is to R, B is to S, and C is to T. AR, BS, and CT, and the corresponding sides that are also congruent because of the markings that we are seeing here will be AB and RS, BC, and ST, and CA, and TR. So even though we are moving the triangles around, we are seeing identical shape and size because of the markings on our triangle. Therefore, if we're going to be naming corresponding parts of a figure, we are seeing a trapezoid, which is ABCD, quadrilateral, and TRQS, that is known to be congruent because it's given. All we need to do is to write out the given corresponding parts, or write out the corresponding parts of this quadrilateral that are congruent. So we can start with the angles. So we know by our clues here, AB is corresponding to TR because they have the same color and so on. So if we're going to start with listing down the corresponding angles, we can start with A is corresponding to T is congruent to angle T, and we have angle B congruent to angle R, C congruent to Q, and D congruent to angle S. So these are now our corresponding angles that are also congruent, and for its sides, we can start with AB congruent to TR. Now notice that there's no math procedure or calculation involved. All we need to do is to understand how we write notations in geometry to be able to complete our work. So BC is congruent to RQ, and they're also corresponding. And then CD is corresponding to QS. And the last segment, we have DA. This is DA, congruent to line segment ST. So this is how we write out our notation for congruency of our corresponding parts, because we know that trapezoid ABCD is congruent to trapezoid TRQS. And we are also going to use this theorem to be able to figure out the measurement of angle F in this problem, knowing that triangle ABC is congruent to AEF. AEF. And when they are congruent, we know that its corresponding parts are also congruent. So with that, all we need to do is to figure out a way on how to find angle C so that we can find the value of angle F, because they are corresponding and they are also congruent. And using the angle sum theorem, we know that the interior angle of any triangle is equal to 180 degrees. So if we're going to add the measurement of C and the measurement of B and the measurement of A, or angle A, it will equal to 180 degrees. And we know that B and A are given, and B and A are 96 and 36, which is equal to 180 degrees. And the measurement of angle C is unknown, so we'll just write the measurement of angle C. And by doing algebra, we are going to combine like terms and subtract it from 180, and we'll be able to find the value of the measurement of angle C, which is, in this case, measurement of angle C is equal to 48 degrees. So now that we're able to find the value of angle C, which is 48 degrees, and we know that ABC is congruent to AEF, C and F should have the same value, so we'll have 48 degrees for the measurement of angle F. And that is how we look for the missing parts of any corresponding triangles using our theorem. And the next theorem that we're going to be using is the third angles theorem. And from this theorem, we know that if the corresponding angle A and B that are congruent is also, or we also have corresponding angle B and E to be also congruent, even though we don't know about any information on the third angle or angle C and F, we can say that angle C is congruent to angle F because of the third angles theorem. And this is what we're going to be using so that we'll be able to figure out a way on how to solve for X, the value of X of our triangle. So I've already shared with you my first step, and the measurement of angle K is equal to 180 minus 53 minus 92 degrees equal to 35. And we're able to establish that using the interiors, or the sum of the interior angles of a triangle is equal to 180 degrees. So since angle K is missing, the easiest angle to find here is adding 92 and 53 and subtracting it from 180, which is equal to 35 degrees. So now that we know that angle K is 35 degrees, finding the value of X will be easier because we're going to be using the third angle theorem, because if we know that the measurement of angle C is congruent to the measurement of angle Q, and why can we establish or write that? Because of the third angle theorem, because we know that J is congruent to R and H is congruent to S, and they are corresponding. So the third angle is also going to be congruent. So now that we know that angle C is 35 degrees, equal to the measurement of angle Q, which is 10x plus 5 degrees, all we need to do is to use algebra. So we subtract 5 on both sides, and we'll have 30 is equal to 10x, and divide both sides by 10, so that x is equal to 3. And that's how we're going to find the value of x in this problem using the third angles theorem. And by doing so, we'll be able to find the measurement of q. And without even doing the math, we know that q will end up 35 degrees because they are corresponding, and we know that the triangle is congruent from the measurements that we are seeing in this given triangles. So now that we know that all we need to do is to equate k and q, we can check using algebra that if we substitute the value of x to 10x plus 5, it will equal to the measurement of q, which is 35 degrees. Therefore, 35 is equal to 35. So this is our solution for this particular triangle problem, and we're able to solve this using the interior sum angle formula and the third angles theorem. And since the parts are corresponding, using the third angle theorem, we can say that the measurement of k is congruent to the measurement of q, or the measurement of k is equal to the measurement of q. So this is how we know that the triangles that we are seeing is indeed congruent. So this is how we use algebra and geometry together. Now, let's prove using the theorems that we have that these triangles we are seeing are congruent. And where are the triangles that we are talking about in this figure? We know that it looks like a diamond, but we know that LMN, or triangle LMN, is also, well, not congruent yet, but we know that we also have another triangle LNO in this figure. So these are the two triangles that we're going to prove are congruent using our theorems. So we know from the given information that we have LM, which is congruent to LO. So this is LM and LO, and we know that they are congruent because 1, it's given, and 2, because they have the same number of markings, which is 1 line for LM and ON. And we also know that MN is congruent to ON because they have the same number of markings as well right here. And of course, it's the given information that we have from this problem. So by doing this, we can tell that they are sharing the same line right here, which is line LN. And by doing this, we'll be able to establish the reflexive property because we know that LN is present to triangle ONL and also NML. That's why the reflexive property will be very useful in proving that triangle LMN is congruent to triangle LON. And the next thing that we're going to establish is to show that angle M and O are congruent because they have the same marking as well. And we also know that angle MLN and OLN are also congruent because they have two markings on that corner as well. And we also know this because it's also a given information from our problem, which is this line right here. And now that we establish line 1, 2, and 3, we can now move on and work with triangle, or this little angle right here, because we know that these two corresponding angles are congruent because it's given. We know that these two angles are also congruent because it's given. So how are we going to know that these two right here are also congruent? And your guess is as good as mine because this is the third angle that is left in our triangle. So by doing so, we can establish that angle MNL is congruent to ONL, and we are able to write that down, not because we are seeing the symbols in our figure, but because of the third angles theorem. So now that we know the reason from our statements, we have one last line to fill, and that is to prove that LMN is indeed congruent to OLN because we know that the corresponding parts of the two triangles are congruent. MO, MLN, and OLN, and MNOL and MLN Oh, so now we know, using the definition of the congruent triangles, that LMN or triangle LMN is congruent to triangle LON. So this is how we use the two-column proof when we're working with problems similar to this one. And now we're able to prove this statement that we start with a little while ago. So now that you know how to prove, let's see if you can answer this Numberbender challenge of the day. And from here, you need to find the measurement of angle E using the theorems that we have learned today, and I'm sure that you'll be able to solve this easily. And comment it down below if you know the answer to this question. And this is our lesson on congruent triangles and how the corresponding parts of the triangles are congruent using the theorems that we have learned in today's lesson. So in working with two-column proof and answering measurements of our geometric figures, we just need to know how to use our theorems so that we'll be able to understand how geometry works in shapes that we are dealing in geometry. This is Dr. E, and see you again next time.